All right, so now that we have that covered, I think we've done enough to get back to your original question about rendering. So rendering is the process by which React runs the code for your components and then syncs them with the DOM. Calling render the first time causes React to take the output from your components and actually converts them to the elements you see on the screen. And as React runs your components for the first time, it also sets up some internal triggers like events that can in the future tell React to call your component again and get the updated output. So every time React calls your function, that represents your React components, it is called a render. So really, React is actually very simple. Like I said before, it just calls your component or child components over and over again. And a child component is any React component that you return in your JSX from a React component. So you can have a parent React component with multiple children React components. And so when you define a React component, you should just think of it as an isolated entity that can get called one or many times. And you don't have any direct control over when your function or React component gets called. React is allowed to call it as many times as it wants, whenever it wants. This is another important reason why you shouldn't have direct side effects in your React components. Okay, I think I see. The way you describe it with child components makes it sound like a tree, kinda. Is that a good way to think of it? A tree! Yes, exactly. Your React program will be made up of a tree of React components. Okay, I think we can now talk about the rest of the rendering process. So React starts by calling your top level component, highest up in the tree, and that component returns JSX that includes other components. React just works its way through the JSX, calling all the components that you've defined. Eventually, it makes its way through your entire tree of React components, and it is left with just plain native HTML elements, defined in your JSX, basically. All of your React components eventually decompose down into HTML elements of some kind. Let's say your calendar component is made up of a bunch of divs and spans and whatever. Eventually, by executing your React components, your functions, React ends up with a bunch of just basic HTML elements, right? But how does it go from this tree of HTML elements to actually putting something on the screen? And what happens if a user triggers an event or state change? This is the fun part that makes React react. And that is called reconciliation. So remember how React goes through and executes the code for your tree of React components and ends with a tree of JavaScript objects representing the HTML elements? Well, the first time, it just goes through that tree, and using the browser's built-in JavaScript APIs, it creates all of those elements and puts them on the screen. But it also stores that tree representing the current state of your React application. And then if, say, a user clicks a button on the calendar to change the month they're viewing, the click event tells React that it needs to re-render the calendar component that the user interacted with. So React then runs your code for the calendar component with the state being updated to reflect the new month to display and returning a tree again. Now it then reconciles this new tree with the tree it stored before. And if it detects any differences between the trees, it updates what is on the screen to match the new screen. And this is if you have ever heard of the virtual DOM in reference to React. This is basically what it's referring to, this internal tree that React is storing and analyzing and reconciling that represents the state of your React application. In fact, the earliest versions of React were much simpler. They didn't even have a virtual DOM. They didn't have these, they didn't store these trees. Instead, anytime there was a user interaction or state change, they just deleted all of the elements that it initially added to the screen. It then reran all of the code of all of the React components and converted the output to what you see on the screen. Basically, it just reran the program over and over again. Every single time there was any change, blew away everything on the screen and rebuilt it all. And this is actually conceptually still a very good way to think of how React works. Technically, it's not how React works, and we're going to get into that a little bit more. But conceptually, you can absolutely imagine that's the way React works, and that will basically cover all normal uses of writing a React program. Okay. So I'm just a sea slug here, and this is a lot. Can you give me a chance to extend my gills and catch some oxygen at least? Yes, yeah, absolutely. It is a lot. You're right. Okay, thank you. All right, so let me see if I got this right. So in summary, are you saying that I can just imagine that React runs all the code for all of my components anytime some state might have changed? And then I imagine React deleting everything that it added to the screen and replacing it with the new output from my React components? Yep, conceptually, that's exactly how React works. So basically, I don't need to do anything to actually tell the browser what updates to make when the user interacts with my calendar. React just kind of magically takes care of it for me? Yes, exactly. And that is what makes React React. You just declare how your components should function. And React takes care of making sure the browser is in sync with what you've declared. Without React, in just plain JavaScript, you have to manually call JavaScript APIs to update what is on the screen to match the state of your program. With React, however, you only need to keep track of the state updates and how you want things to look and behave on the screen. You don't actually need to do anything with the browser DOM APIs. React handles that all for you. It reacts. What? Wow, that's so cool. Now I see why React is useful. It sounds like it eliminates a lot of manual work I would need to do otherwise. Yes, and that also eliminates an entire class of bugs that might crawl out from the rock next to you, Norris, where you might make a mistake in that stage of your program, where what the browser shows on the screen becomes out of sync with the internal state of your program. It's something that I ran into all the time when trying to program back in the day with jQuery and just plain JavaScript. You would end up with your program for, the calendar, thinking it's showing the month of April, but you didn't get the, connection right to the browser, and the browser is still showing February on the screen or something like that. Awesome. Neato bandito. So that whole thing about React, reconciling and storing trees and stuff is really just irrelevant. Like, why did you tell it to me? Do I actually need to care about any of that? Okay, well, that is an astute observation, Norris. But the answer is, unfortunately, kind of. I wasn't just telling you that for no good reason. So remember how I said that initially React didn't do this whole tree reconciliation thing and just reran all of your React code all of the time and rebuilt the on-screen content from scratch each time? Well, that absolutely did work, and it still would work. But for complex applications, it is just too slow. So React decided to make some performance optimizations. To render your React program react executes the code for your components and stores the tree of output, like we talked about, after putting everything on the screen. Then whenever an event occurs or React thinks some state might have changed in your components, it reruns all or at least some of your components' code. Your components again output this tree of nodes. React then compares the new output to the output it stored from the previous time it rendered all of your components. And if there are any differences in the output, React will update the DOM elements on the screen to match the new output from your components. It does not touch or change any of the DOM elements higher in the tree that it doesn't think have changed. This is the performance optimization. It allows those elements on the screen to stay the same. React doesn't have to run a bunch of extra code to, delete them and re-add them to the screen. But how does React actually detect when something in the tree has changed? It has these two trees, right? But how does it actually detect when these trees are different from each other? There is an algorithm in computer science that lets you detect differences between trees. If React used that algorithm, the performance optimizations would be completely transparent and we wouldn't be talking about it now. So obviously React doesn't use that algorithm because that algorithm is too slow. Again. So instead, React created their own algorithm that tries to guess when the new output differs from the previous output, or when parts of the tree differ from each other without needing to sort of look in depth at the entire trees every time. This process is called reconciliation. Oh, of course. Yeah, so, okay, let me try to... Okay, hold up. I'm not sure you can call my basic slug nervous system a brain, but whatever you call it, it needs a chance to catch up here. Okay, of course. Okay, so let me try to recap this. Rendering is the process React takes to run my component's code and figure out what changed from the previous run so that it can update what is on the screen to match the latest output from my components. Reconciliation is a part of the rendering process where React actually figures out what changed so it knows what to update on the screen. Did I get that correct? Yes. If they don't call your nervous system a brain, they absolutely should, because you nailed it. Thank you. Okay, so what is it about the performance optimizations then that I actually do need to know about or care about? Unfortunately, yes, you do need to care, and there are a few things. For the most part, it is transparent, but there are a few things you do need to be aware of. So reconciliation is done by comparing the types of the nodes within the trees. So if the node in the same place in two trees are of the same type, like if the top node in both trees are divs, then React knows it doesn't need to create a new DOM element and add it to the screen. It could reuse that div that's already on the screen, right? So it goes through both trees, comparing the nodes in the same places in the trees. If it detects any type changes between the two, it destroys all of the DOM elements on the screen from that point in the tree down and rebuilds them with the output from the new tree. So if your component used to return a div and now it returns a span along with maybe some other React components, it's going to destroy and remove the original div and everything inside of it from the screen and rebuild it from the new tree. So in technical terms, this is called a heuristic algorithm and is generally transparent to you as a programmer. You don't normally need to think about it except if you're specifically trying to optimize the performance of your program. but there are some special cases where you do need to be somewhat concerned about it, even if you're not doing performance optimizations. And a special case where you do need to do some extra work to help out this heuristic algorithm is when you have a component that renders a list of other components or a list of other HTML DOM elements. Like if you iterate over an array to build a list in your output, then you have to do something special. The first node in the output for the list needs to have the special property set called key. React takes a shortcut on lists and doesn't run its full heuristic algorithm. Instead, it only looks at the key property to determine if it needs to update the DOM element on the screen. So whenever you render a list, you need to specify this key property, and its value should be unique for the data in each list element, and it should be stable, meaning it should always be the same value every time your component renders for that same list element. I know this sounds like a lot, but React will remind you in the warnings if you ever forget the key property. And at least without getting into performance optimizations, that's pretty much it for rendering and reconciliation. Whew. Okay. Wow. So really, I don't need to care too much about how all of that works. I just need to make sure to specify the key property in list items. Is that correct? Yes, exactly. In normal React programming, that is really the only extra thing you need to care about. Now, if you have performance issues, then knowing how that heuristic algorithm works is important because you can use it to your advantage to make your React programs faster. But I don't ever think or worry about it, except if I actually detect a performance issue. Okay, so it sounds like, in summary, if I'm getting this right, Thomas, React works by just running my component code whenever it thinks it needs to, and then by comparing the trees of output between renders, it can keep the internal state of my program in sync with what the user sees and interacts with on the screen? Yes, that is an excellent summary. Now I need to figure out how your slug nervous system works because you are one excellent student. Well, I'm not sure it is compatible with your system, but maybe we can run a reconciliation algorithm on our nervous systems and see the difference sometime. Okay, yeah, absolutely. How about you get your new React ticketing system web application working, and we can use your new calendar component to schedule a time to do a nervous system reconciliation. I can't wait, Thomas. Maybe I can even sell tickets to that event. Yeah, I would love that, Norris. I just want to thank you once again for joining us. I had a lot of fun talking through the mechanics of React in a super condensed and fast way, and I hope it is helpful to you. Yeah, absolutely. I feel like I understand React a lot better now. I think I will need to practice and read the documentation and look at some examples to fully get it. But at least I now know how it all fits together.